everybody, welcome to A to Z Learning Hub. Today we start error analysis part 2. This is part 2 in quantitative manner. This topic we calculate error in mathematical form. You see, there are three types of error. Three types of errors. First one is absolute error. Second one is relative error, or you can say fractional error. And third one is percentage error. These are the three types of error. We read one by one. First you see absolute error. Absolute error. What is absolute error? The absolute error of the measured value of a physical quantity is the difference between true value and measured value. Difference between true value and measured value of physical quantity. What is true value of a physical quantity? The true value of a physical quantity, true value of physical quantity is the arithmetic mean of different measurement of that quantity. Now explain it. Let a physical quantity is measured n times and the measured values are A1, A2, A3, An. So, its true value. So, its true value, that is M is equal to what? A1 plus A2 plus An divided by n. You take its arithmetic mean. That means we add all the measurements and divided by n. Now, the absolute error of a first measurement, your first measurement is A1, that is delta A1, you write it as, remember, delta A1 is equal to Am minus A1, you remember. The absolute error of a first measurement, that means A1 is Am is equal to what? True value minus E1. For second measurement, delta A2 is equal to Am minus A2. Similarly, delta A3 for third measurement, Am minus A3. Continuing in this manner, absolute error of a nth measurement, delta An is equal to Am minus An. You see, this absolute error of each measurement, it may be positive, it may be negative, or in some cases it may be zero. Here, absolute error of each measurement may be positive or zero or negative. In some cases, mean value is greater than individual measurements. In that case, it is positive. In some cases, mean value is less than individual measurement. In that case, it is negative. And in some cases, mean value is equal to individual measurement. In that cases, it is 0. You remember. So, these are the absolute error of each measurement. Now, the mean absolute error. Now, the mean absolute error, of the whole measurement is the arithmetic mean of the magnitude of individual absolute error. You see, what is mean absolute error? Mean absolute error, you write delta A bar is equal to what? Delta A1 mod plus delta A2 mod plus delta an mod divided by n. That means if you take mod of all these absolute error, these are all positive. So, delta A bar, this is the mean absolute error of the measurement, is what? Delta A1 plus delta A2 plus delta an divided by n. This is the mean absolute error of a whole measurement. Now, we write the physical quantity as what? That is AM, that is the true value plus minus delta A bar. That means it is the true value and this is the mean absolute error. Either it is added to AM or it is subtracted from AM, from mean value. This is the absolute error and mean absolute error. Next come to your relative error. Second error is relative error. You can write relative error ER is equal to, we can say also fractional error is equal to what? Mean absolute error divided by your mean value. That is ER is equal to mean absolute error is delta A bar divided by your mean value. This is the relative error or fractional error. Next come to your percentage error. Percentage error EP, you can write absolute error, relative error into 100, this percent. That means percentage error is equal to delta A bar by AM into 100%. This is the percentage error. Now I am doing one problem about this. This is the absolute error and here it is the relative error, is the mean absolute error divided by mean value, and next come to your percentage error. Percentage error is what? Your relative error into 100%, that is EP is equal to delta A bar by AM into 100%. Now, we do a problem, find percentage error of following measurement. Find percentage error of a following measurement, that is 5.1, 5.2, 4.9, 5 and 5.1. We find its a percentage error. You see, there are 5 measurements. First you find mean value. Mean value of a measurement, that is equal to 5.1 plus 5.2 plus 4.9 plus 5 plus 5.1 divided by 5. You add all these. 5.1, 5 plus 5 plus 5 plus 5, your 1, 0.1, 0.3, your 0.9. 1.3 plus 0.9, this is your 1.2 plus 1, 1.3. 5 plus 5 plus 20 plus 4, 20 plus 4, that is equal to 24 plus 1.3, that is equal to what? 25.3 divided by 5. You divide 25 divided by 3, that is your 253 by 50. 253 by 50, that is your 55 ja 250, this is your 3, you just 0, 06, that is your 5.06. 5.06 is your mean value. Now, we find mean value of the measurement. Now we find individual absolute error. Absolute error of a first measurement, that is delta A1 is equal to 5.06 minus 5.1. 5.06, this is your 4, 5.1, 5.06, this is your 10, 4, there's your 4, and this is your 0, there is your 0 point, which is greater? 5.06, 5.1 minus 0.04. Similarly, delta A2 is equal to what? 5.06 minus 5.2, that is your 5.2 minus 5.06, this is your 4, this is your, that is your minus 0.14. Similarly, delta A3 is your what? Your 5.06 minus 4.9, 5.06 minus 4.9, this is your 6, and this is your 0.16, that is a plus 0.16. Delta A4 is your 5.06 minus 5, that is equal to 0 minus 0.06. Then delta A5 is your 5.06 minus 5.1, your first case, that is a 0 minus 0.04. Now, these are the individual absolute error. Now, we find mean absolute error. Mean absolute error, that is equal to delta A bar is equal to what? Delta A1 minus 0.04 mod, that is 0.04 plus 0.14 plus 0.16 plus 0.06 plus 0.04 divided by what? Divided by 5. You take absolute value of all the measurements, that is 0.04 plus 0.14, 0.16, 0.06 plus 0.04. That is what? 4, 6 plus 4, 10, 16 plus 20, 24, 24, 2 taking 2, 2 plus 1, 3 plus 1, 4, 0.44. So that is your what? Delta A bar is equal to what? 0.44 divided by what? 5. 44 by 500, you give 44 divided by 500, 0, you give another 0, you give 0, 58, 54000, that is your 400, then you give another 0, that is equal to what? 0.08, 0.088. This is your mean absolute error of the whole measurement. Now we can write the physical quantity as AM plus minus delta A bar, that is equal to what? Your what is your AM? Your AM is 5.06 plus minus 0.088. This is your value of the physical quantity. Now again come to your relative error. ER is equal to what? Your delta A bar divided by AM, that is equal to 0.088 divided by AM 5.06, and your percentage error, you calculate it, your percentage error is what? 0.088 divided by 5.06 into 100. This is the percentage error. So these are the absolute error, relative error and percentage error. You calculate these two. Next come to your combination of error. There are more than one terms. When we combine them, having errors, when we combine them, how can we determine the error? First you see, first point is error of sum. Suppose the maximum absolute error, the maximum absolute error of the sum of two quantities, sum or a difference you can write. Sum and a difference, I write it. The maximum absolute error, sum or difference of two quantities is equal to sum of the absolute error, sum of the absolute error of individual quantities. Suppose you take one measurement, that is x is equal to a plus minus delta a. Here it is the true value and it is the mean absolute error. And y is equal to what? B plus minus delta b. Now we add these two terms and we subtract these two terms. You see, now we add, let x plus, first point, now x plus y, when we add x with y, let I get a plus minus delta a, addition term. x plus y is equal to a plus minus delta a. That is a plus minus delta a is equal to what? A plus minus delta a plus b plus minus delta b. That is a plus minus delta a is equal to what? A plus minus a plus b plus minus delta a plus delta b. You see, plus minus delta a plus minus delta b, that is your what? A plus b plus minus delta a plus delta b. But you see, here a is the true value of x and b is the true value of y, and x plus y, when we add x plus y, that is the a, is the true value of x plus y. So that is here a is equal to, you write a is equal to what? True value of first measurement plus true value of second measurement. You remember this. So a plus minus delta a plus minus delta a is equal to what? True value of first plus true value of second plus minus absolute error of first plus absolute error of second. So you write, so a plus minus delta a is equal to what? In this case you write a plus minus delta a plus delta b. So you cancel a. That is your delta a plus minus delta a is equal to what? Plus minus delta a plus delta b. You see, delta is the sum of the error of two terms, and which is equal to delta a plus delta b. When we find its maximum value, we can write there are four possible values. That is, there are four possible cases: delta a plus delta b, minus delta a plus delta b, delta a minus delta b, and minus delta a minus delta b. So our aim is to find maximum error. So we determine, that is, delta a is equal to your delta a. You remove this. Delta is equal to what? Either you take both are plus means maximum error. Here minus means here is also maximum error. So delta is equal to what? Delta a plus delta b and minus delta a minus delta b. So we write, so delta a is equal to what? Plus minus delta a plus delta b. So you remember, we cancel these two terms because here one is positive and here it is positive and here it is negative, here it is positive and here it is negative. So you get maximum error. So you take both are plus or both are minus. So delta is equal to plus minus. You take this, or your delta is equal to plus minus delta a plus delta b. Similarly, in case of difference, you find x minus y. I take it as a subtraction. S, suppose x minus y is equal to s plus minus delta s. So s plus minus delta s is equal to what? A plus minus delta a minus b plus minus delta b. That is s plus minus delta s is equal to what? A minus b, and here this is your plus minus delta a plus delta b. Here plus delta a, you will write plus delta a minus plus minus delta b. You see, plus delta a minus plus minus delta b means minus plus delta V minus plus. So you see here also there are 4 possible values. You can write plus minus, I write plus minus delta A plus delta B. Here there are 4 possible values, delta A plus delta B, delta A minus delta B, minus delta A plus delta B, and minus delta A minus delta B. From this we get these 4. So in case of addition or subtraction, whatever it may be, but we always try to find the maximum absolute error. So for a maximum absolute error in positive direction, we choose this case and in this case. So we write S plus minus delta S. So S plus minus delta S is equal to, I get A minus B, this is your S, this is the mean value, plus minus delta A plus delta B. I can write S cancel, plus minus delta S is equal to what? Plus minus delta A plus delta B. And since I choose maximum error, so we find delta S is equal to what? Plus minus plus delta A plus delta B or minus delta A minus delta B. In case of a subtraction also, I write delta A plus delta B. So you see, in case of addition and subtraction, A plus minus delta A plus B plus minus delta B is equal to what? A plus B plus minus delta A plus delta B. You always add the error term. Similarly, this is for addition, and in case of a subtraction, A plus minus delta A minus B plus minus delta B. Here we get A minus B. You subtract, in this case you add mean value with mean value. Here you subtract mean value from mean value, but error term must be added. That is equal to what? Plus minus delta plus delta A plus delta B. So that we get maximum error either in a positive direction or a negative direction. So the rule said, in case of addition and subtraction, the maximum absolute error is the sum of the error in the sum or a difference of the quantities is equal to sum of the absolute error. In case of addition, all the mean values are added, and in case of subtraction, all the mean values are subtracted, but error terms must be added in both cases. For example, I am doing one problem. Suppose question number 1, suppose 3 plus minus 0.01 plus 4 plus minus 0.02. Add. Your first question, first bit. Your second bit is 5 plus minus 0.02 minus 3 plus minus 0.01. Subtract. You see, in case of addition, first case I am doing 3 plus minus 0.01 plus 4 plus minus 0.02. You see, in this case, the mean value is 3 plus 4, that is your 7. You write plus minus 0.01 plus 0.02. That is your what? 7 plus minus what? Your 0.03. This is your answer. You see, in case of a subtraction, that is 5 plus minus 0.02 minus 3 plus minus 0.01. In this case, what will do? You subtract mean value from mean value, that is your 5 minus 3, that is your 2. But you add the error term, that is 0.02 plus 0.01, that is equal to 2 plus minus 0.03. You remember one thing, In case of addition and subtraction, all the mean, in case of addition, all the mean values are added, but the error term must be added, and in case of subtraction, all the mean values are subtracted, but the error terms must be added in order to get maximum error either in positive or a negative direction. Next come to your errors in product. Errors in product. How can you do? You see, suppose the maximum fractional error or relative error of the product of quantities is sum of the fractional error of individual quantities. You see, how can you do it? Suppose a measurement there Z is equal to AB. So, this is the true value. But you can write delta Z is error of a Z. So, I write Z plus minus delta Z is equal to what? I can write A as A plus minus delta A into B plus minus delta B. Now we multiply. Z plus minus delta Z is equal to what? AB plus minus A delta B, your plus minus delta A into B, delta A into B, your plus minus delta A into delta B. Now dividing both sides by Z, dividing both sides by Z, that is your Z by Z plus delta plus minus delta Z by Z, that is your what? AB by Z, your AB is equal to Z means 1 plus minus A delta B by Z, Z means AB plus delta plus minus delta A into B divided by AB plus minus delta A by A into delta B by B. You write, this is your Z by Z is your 1 cancel, that is your 1 plus minus delta Z by Z is equal to 1 plus minus delta A, you write delta A by A plus minus delta B by B, here A cancel, and this term is cancelled because delta A by is very small and the delta, there are two deltas are there, so these terms are neglected. So we can write here 1 cancel plus minus delta Z by Z is equal to what? Plus minus delta A by A plus minus delta B by B. You remove minus signs, or we can write delta Z by Z is equal to what? Delta A by A plus delta B by B. So, you see the maximum fractional error or a relative error of the product of the two quantities. This is the absolute error, mean absolute error, this is the true value, is equal to what? Sum of the fractional error of the individual quantities. There are two quantities A and B. This is the absolute error of A and this is its mean value, and this is the absolute error B and this is the mean value. Similarly, your third rule, error in division. What? The maximum fractional error or relative error of a division of a quantities is sum of the fractional error of the individual quantities. You see, let Z is equal to what? A by B. Let delta Z is the error of Z. I can write Z plus minus delta Z is equal to, I write A plus minus delta A divided by B plus minus delta B. I can write Z plus minus delta Z is equal to A plus minus delta A into B plus minus delta B whole to the power minus 1. I can write, you see, Z plus minus delta Z, we can write here, you take A common, this is your 1 plus minus delta A by A, and here you take B common, that is the B to the power minus 1, 1 plus minus delta B by B whole to the power minus 1. So, we can write Z plus minus delta Z is equal to what? Your A into B to the power minus 1, that means A by B into what? 1 plus minus delta A by A into, I write it, 1 minus delta B by B. You see what is the formula? You see why it is, here the power is minus 1, here this minus come to this side. You know, for x is very very less than 1, 1 plus x to the power n, 1 plus x to the power n is equal to what? 1 plus nx. You see, this formula you remember. Here this is your 1, this is your x, this is your 1, this is your x, and this is your n. Since delta B by B, you know delta B is a very very small term, by B is very very small and it is very less than 1 to the power minus 1, 1 plus x to the power n is equal to what? 1 plus nx, here n is equal to minus 1, that is equal to, right, 1. I can write the minus come to this side, this will be what? This is your plus minus, this is plus minus, when a minus is multiplied here, this is your minus plus. You remember, here when n come to this minus 1 come to this side, this is your plus minus into minus, minus into plus, that is your minus, and this is your plus. You write, you remember this formula, 1 plus x to the power n is equal to 1 plus nx. When this x is very very less than 1, I can write, put A by B is equal to Z, Z plus minus delta Z is equal to Z into 1 plus minus delta A by A into 1 minus plus your minus plus delta B by B. I can write, divide both sides by Z, I can write 1 plus delta Z by Z, that is equal to what? 1 plus minus, you divide by Z, your 1 plus minus delta A by A into 1 minus plus delta B by B. So, I can write 1 plus minus delta z by z is equal to what? Multiply. This is your 1. This is your 1. Your minus plus delta b by b plus minus delta a by a. Your plus minus delta a by a into what? Delta b by b. And now we remove this one term, and this term is also removed because there are two deltas. So plus minus delta z by z is equal to plus minus delta a by a minus plus delta b by b, or we can write in addition term, we can write delta z by z is equal to delta a by a plus minus, plus, you take only plus sign, delta b by b. So we can write the maximum fractional error or a relative error of a division of quantities is sum of the fractional error of individual quantities. So in case of addition and subtraction, the error terms are added, but in case of multiplication and division, your sum of the your fractional or total fractional error of a product or a division. Here this is the, in the previous case, delta z by z is the fractional error of a product. Here delta z by z is the fractional error of a division is equal to what? Sum of the fractional error of individual quantities. These are the formula. You see, next come to your errors in the power. Your fourth rule, errors in power. You see, let the fractional error of nth power of a quantities, the fractional error of nth power of a quantity is the n times of the fractional error, is the n times of the fractional error of that quantity. You see, suppose z is equal to what? A to the power n. If delta z is error term of z, we can write z plus minus delta z is equal to what? A plus minus delta a whole to the power n. So we can write z plus minus delta z, you take a common, so when it comes outside, that is a to the power n, 1 plus minus delta a by a whole to the power n. So we can write z plus minus delta z is equal to what? Z 1 plus minus, again we apply that formula, 1 plus x to the power n is equal to 1 plus nx, when x is very less than 1, this term is very less than 1, this term we can write n delta a by a. When you expand it, now dividing both sides by z, we can write 1 plus minus delta z by z, your 1 plus minus n into delta a by a. We would cancel 1 and 1, you get delta z by z plus minus delta z by z is equal to plus minus n into what? Delta A by A. You remove negative sign, delta z by z is equal to n into delta A by A. This is the formula. You remember. So the fractional error of nth power of a quantity is n times of the fractional error of that quantity. Similarly, in general case, suppose it is given, suppose z is equal to a to the power p by b to the power q by c to the power r, we can write delta z by z is equal to what? P into delta A by A, here this is the product, plus Q into delta B by B plus R into delta C by C. You remember this formula. This is the general formula. That means when the powers are given, you find the fractional error of each measurement and you multiply the power and add, we get delta z by z. This is the error analysis, and we find the formula of different cases: errors of sum, errors of difference, errors of product, errors of division, and here this is the errors of power. These are the formulas. You remember all these formula. Here there is one formula, delta z by z is equal to n into delta A by A. Here there is one power, but in this case there are three powers. Here delta z by z is equal to p into delta A by A plus q into delta B by B plus r into delta C by C. Now I am doing just one problem. Find, question number 1, 3 plus minus 0.01 whole to the power 3. You write, let z plus minus delta z is equal to 3 plus minus 0.01 to the power 3. Here z is equal to what? I find z and delta z. Here z is equal to 3 to the power 3, that is your 27. Now I apply the formula, delta z by z is equal to 3 into delta A by A, that is your delta z by z. Z is your 3 into delta A by A, that means 0.01 divided by what? 3. So delta z is equal to what? 3 into 0.01 divided by 3 into what? This is your z. That is your, you cancel 0.01 into z. Z is your 27. That is your 0.01 into 27. That is your 0.27. 0.27. So our measurement is, we find it delta z and we get z. So z plus minus delta z is equal to what? That is your 27 plus minus delta z. Delta z is your what? 0.27. This is the answer. If the measurement is, measured quantity is 3 plus minus 0.01 whole to the power 3. So I can write, first we find z plus minus delta z. Z is equal to third power of true value, that is the 3 to the power 3, that is your 27. Then we apply the formula, delta z by z is equal to n is equal to 3, that is equal to delta A by A, that is delta z by z is equal to 3, your 0.01 divided by 3, that is your delta z is equal to z, then 0.01 into 27, that is equal to 0.27. So our required measurement is this. So this is for today's class. So if you like my channel, please subscribe my channel, share my channel, so that I will be motivated to give you better and better video. For today's, thank you everybody.